Hello, everyone. Welcome to Start 1220 Elements of Statistics. So, this will be our first lecture video to cover what we did in our first week. So, I'm tackling the section 1.1 through 1.3. I hope to summarize everything in 10 to 15 minutes. Then, if you are watching this video, you can pause and rewatch it at any point in time for better understanding. So I'll be going through it very fast so that I can cover that 10 to 15 minutes as well as getting all the information that you need to get in this lecture video. Okay, so I'll begin. So in our first week, we talk about statistics. So what do we mean by statistics? So we are saying that statistics is a science. So statistics is a science of collecting, organizing, summarizing, interpreting data, and analyzing information to draw conclusion. So here, statistics has been in two parts. So the first part deals with the collecting of data, and the other part deals with analyzing information to draw a conclusion. So as we move forward, we're going to know these two parts that form what? Statistics. I've made mention of data. What do you mean by data? Data is any information that you are getting from an individual in a population. As I move ahead, you're going to understand what we mean by a population or a sample. So data is information. So this information could be what? Counts, it could be responses, it could be measurements and observations. And we have examples of these as you see. So there are types of data. One of it is the population data and the other is what? The sample data. So the population data deals with all the counts that you are getting, and the sample data is a subset of the population. If I take the class for instance and I want to get the age of each and everyone in the class, then I'm getting some kind of data known as what? The population data. If I take a part of the class and get age of each and everyone, then I am getting what? The sample what? Data. So population is the collection of all outcomes, whilst a sample is a subset of the population. So with this diagram, you can see what we mean by population data and a sample data. Okay, so these are examples for us to determine whether a data is population data or a sample data. So I'll do these examples very fast. So we are getting the age of each member of the House of Representatives. So each member, so we have the House of Representatives. So if you are getting the age of each and every one there, then you are getting a population data. If you want to get the height of every fourth person, so not the height of everyone, so the height of every fourth person, then this data is a sample what? Data. And if you want to get the annual salary of each lawyer at a firm, so each lawyer at a firm, so this is what? A population what? Data. Okay. So whenever you get this data, we want to get some numerical description of that data. Some could be the numerical description of your data, which is what? A population data. It could be that of what? A sample what? Data. And this numerical description that you are getting from the population is called what? A parameter. If you are getting this numerical description, it's termed as what? A statistic. It's termed as what? A statistic. So let's determine whether these examples, whether this numerical description of the population is a statistic or is a parameter. So the statistic depends on what? The sample. The parameter depends on what? On the population. So if you're able to know that this is a population data, then the numerical description is what? It's a parameter. If you're able to know that this is a sample data, then the numerical description is what? It's a statistic. So I'll go through the first two examples, then the other examples has been explained. So you're getting the average annual salary for 35. So we have 35 of a company's 1,200 accountants. So we have a sample data here. We took 35 out of 1,200 accountants. So this is sample data. And we had their average annual salary, and that is what? $68,000. So this is the statistic that we're having here. The same applies to a sample of high school students. So we took a sample of what? High school students. So the numerical distribution that comes with it is what? 43%, which is what? A statistic. So the 43% is what? Is a statistic. The same applies to the examples as you are seeing. Okay, so you can go through these examples, and if you have any question, you can ask. Okay, you can pause at any point in time and watch this video. Okay, so remember, from the definition of statistics, I told you that there is a part that deals with what? The collecting of what? Data, and the other part deals with what? Making conclusion from our results. So the first part that deals with what? The collection, interpreting, and summarizing data is the descriptive aspect. So it describes how our data is. So this descriptive aspect is the organizing, summarizing, and displaying data, and the inferential makes some logical conclusion from our result. So we have the descriptive and we have the inferential statistics. So these are some kind of examples of descriptive statistics and inferential statistics. So among 1017 men and women in a sample, it is reported that 76% of men and 60% of men 76% of women and 60% of men had physical exam. So the descriptive statistics here is that you have 76% of women and 60% of what? Of men had physical exam. We are not making any logical conclusion. What does these figures mean? What does these statistics mean? Okay, so we are saying that women seem to be more concerned about their health because a statistic shows that higher percentage of women than men that had a physical exam within the year. Okay, so because of these numbers, we can make some kind of inferences from it. Okay, so that is the inferential statistic. Okay, remember that if you want to get the data, it could be from the characteristics of an individual in the population. So the height, the age, the weight. So if I take you as an individual, the individual is not a person. It could be an object, it could be anything. But if you want to get some kind of information that characterizes this individual, it could be the age, it could be the weight. So if I pick your age characterizes you. And if I pick your weight also characterizes you. So if you put all these together, we call them in statistics, we call it what? The variables. These are what? The variables. Okay. So there are two types of variables. There are variables that qualifies you, and the other one that also quantifies you. It gives you some kind of numerical value. So the qualitative aspect and the quantitative what aspect. The qualitative can also be known as what? The categorical. It can also be known as what? The categorical. This one has no numerical value. So it could be your hair color. It qualifies you. What is your hair color? Qualifies you. It could be attributes, names, labels, so on and so forth. So these are some examples as you can see. And we have the ones that's also what? Quantifies you. The ones that quantifies you gives you the numerical what? Values. And in these numerical values, we have ones that have a finite value. You can't have a decimal in it. And we have the other ones that also has what? Decimals in it. So the ones with finite values, we call them what? The discrete variable. So all of these are quantitative variables. So this is a discrete what? Variable. And the continuous variable also has what? An infinite number of possible what? Values. So the number of pets. So we could have 10 pets. We can have 10.3 pets. So who is the 0.3 pets? That is in it. And the continuous variable also can take some kind of what? A decimal in it or some infinite number. It can take value also in two numbers. So the height, you can have 3.5, you can have 4.6, so on and so forth. So if we have these kind of variables, then we call them the continuous variables. We call them the continuous variables. Okay, so these are some assessment for your understanding, and I have these answers for you to go through. These assess your understanding for what you've just learned, so you can quickly just go through and you'll be good. Okay, so I'll be going through them. Very simple. All right. So there are examples here. Okay, so here in age, you have to determine whether it's a population data, it's a sample. Since we took 1028 teenagers, then we are having what? A sample data. We are having a sample data. We have a table here too, that's 9. We have to know, we have to identify the individuals. So the individuals are the ones you are getting the characteristics from, you are getting the variables from. So the setups are what? Our individuals. And we have the size, you're getting the size from this individual, you're getting the screen type, you're getting the number of channels. So you're getting these variables. So the variables are what? The size, the screen type, number of channels, and the individuals are what? A, B, C, D, and E. Okay, so these variables, remember that I told you that you have the qualitative variable and you have the quantitative variable. So when you pick the size has is categorized is the size is quantitative, but under this quantitative, this size can take any decimal point. It has finite number here, but it does not mean that it's what? It's a discrete variable. So the size is what? A continuous what? Variable. You have the screen type. So the screen type and the variables is what? A qualitative what? Data. It qualifies the setups, the individuals in the population. Okay, and the number of channels is the discrete. You can't have point something in the number of channels. It doesn't happen that way. So this is a discrete variable. Okay, and these are data. Okay, so I've explained everything as I'm going through. Okay, so you can take time and pause and rewatch. Okay, so then you read through, it gives you the summary of what you've learned. Everything has been put in here. So you have questions under it that has been answered. You can go through it and you realize that you are good to go. Okay. So here's the conclusion of the study, which of the following is correct. So the conclusion is just here. So the researcher conclude that cryotherapy is significantly more effective in treating what than DACT. So that's the conclusion. That's the inferential aspect that we are talking about. Okay, so 11, the same as 10. So you can go through and you are good to go. Okay, so we have the answers here to each question that has been highlighted. Okay, so 1.3, so we are done with 1.1. So 1.3, that is the presentation of data. How do we present our data? Okay, it could be in a table form. So we have definition of frequency, data frequency table, and relative frequency. So when you talk about frequency, when you have your data, you want to know, okay, with this data, there is a number that happens oftentimes. So how many times that this number actually happens in our data? That is the frequency of that number. So if you have 2 in your data and 2 comes in like 5 times, then the frequency of 2 is what? Is 5. That is the example. So if we know the frequency of our data points, then we can put them in a table. That is called the data frequency what? Table. So we know your data, so you have to put them in what? In a frequency table. So the relative frequency that we see here is the frequency of that number over the total number of that frequency. It wants to get the proportion that this data takes in our data sets. So 2 comes in 5 times. So what's the proportion that 2 actually get from our total what? Data. So that's the relative frequency. So if you know the frequency of that class 2, then you take it over the total number of what samples that you're having. So the sum of our F is the number of samples that you're having. That's the sigma F. Okay, that's the total frequency. So we have example here. So we have our data here. So you have to use this sample data to create a data frequency table and calculate the relative frequencies of 5 and 8. So we have 5. So this is our data point, and this we have to list the distinct numbers that we see. We see 2, we see 3, 5, 8, and 11. So 2 came in 1 time, 3 2 times, 5 4 times, 8 2 times, 3 2 what? 11 2 3 times. So the total number of data points that we're having is 12. So we have 12 data points here. The number of data points you are seeing here should correspond to your sigma f. You sum all these. Okay, so what proportion does 2 take from this total number of data points? You realize that 2 take just 1 out of 12 of it. You realize that 3 takes 2 out of 12 of it. You realize that 5 takes out of what? 5 out of 12 of it. And 8 takes 2 out of 12 of it. 11 takes 3 out of 12 of it. So when you sum all these relative frequencies, you should get 1 or hat 100%. So this is your relative frequency. This is your relative frequency. So we were asked to calculate the relative frequencies of 5 and 8. So what is the relative frequencies of 5 and 8? So this is 5. So 5 is 4 over 12. And you can convert it to what? Decimal point. And 8 is what? 2 over 12. Can convert it to what? Decimal point, and you are good to go. You are good to go. All right. So this ends the first lecture that we had on Monday. Okay. Thank you all. Let's go to the other lecture. All right.